Assalamu alaikum students. Today we will study chapter 1 of Business Math 101 course, Introduction to Mathematics. This chapter is about power and roots. In other way we can call it exponents. Powers and roots are called exponents. So here first of all we need to understand some of the law or rules of exponents or rules of powers. The first one is, you can see it's saying that a to the power m multiplied by a to the power n. So here you can see in the both case base is a. So in both case base is a, here also a, and here also base is a. So in such case when the bases are same and powers are different, and if you want to multiply, in that case since the bases are same, power can be added together. So that means we will have a to the power m plus n. We will have a to the power m plus n. So that means since the bases are same and we are here multiplying, in that case powers will be added together, right? So next one here also bases are same. Here also in this case, here also base a, here also base a, but powers are different. So here the previous one was in the multiplication, we were doing multiplication, but here we are doing division. As you can see, a to the power m divided by a to the power n. So here a to the power m divided by a to the power n. So here we are doing division. So in division it will be just opposite. So that means here since the bases are same, here also base a, and in the denominator also we have base a, but powers are different. In such case powers will be deducted from the numerator's power, and from the numerator's power we need to deduct the denominator's power. Numerator is called, in Bengali we call it lob, and denominator we call it, in Bengali we call hor. Or in another way we can say it like that: if in a fraction, above part is the numerator and the below part is the denominator. So here you can see in the numerator we have a to the power m, and the denominator we have a to the power n. In both case base is a. So in both case base is a, but powers are different. In such case powers will be deducted. Powers from the numerator's power we will deduct the denominator's power. From numerator's power we will deduct the denominator's power, right? So let's check out the next one. Here you can see we have a to the power m bracket power a to the power n. So that means here we have inside the bracket we have a to the power m, and outside the bracket we have another power which is n. So in such case powers can be multiplied together. Powers will be multiplied together. So that means a to the power, we will have a to the power m multiplied by n, right? So let's check out the next one. Here we have ab power n. So you can see ab power n. So that means if ab is inside the bracket and outside we have a power, and this power will be applicable, this power n will be applicable on both a and b. So that means a to the power, we will have a to the power n multiplied by b to the power n. So now let's check out the next one, number 5 rule. Here you can see we have a by b bracket power a n. So that means this power n is applicable to both a and both b. So we will have a to the power n divided by b to the power n. Now let's check the next one. Now let us check the next one. So here we have a to the power minus n. A to the power minus n. So if we simplify it, that means if you want to remove the power, if you want to remove the minus sign from the power, so what you can do, you can take it to the reverse position. That means you can bring the whole, you can bring the full digit, you can take the power with the, we can take the power with the base in the denominator, where the minus sign will not be there. So that means, I'm saying again, so if you see there is a minus in the power, in that case the power and the base together will go in the denominator without the minus sign. Without the minus sign, you can see that a to the power n is moved to denominator. A to the power n is moved to denominator, but minus is not there. So that means if you want to remove the minus from the power, you can move that one. You can move the base along with the power in the denominator, except the minus sign. Right. So next one we have a to the power half. A to the power half. So a to the power half can also be written as root over a. Always remember, this is square root. This one is square root. This one is square root. Square root means it's a power half. It's power half. That means here, as you can see, here with a there is no power. Here with a there is no power. So that means, in other way we can call it, power is only 1. So that means here inside the square root we have a. So that means here we have only power 1. No power is there. So that means we have power 1 there. Right. So, and square root means half. Square root means 1 by 2. So that means square root means power is 1 by 2. So that means a to the power 1 by 2. A to the power 1 by 2 is square root. Again, this is a to the power 1 by 3. A to the power 1 by 3. So this is cubic root. This one is called cubic root. This one is not square root. This one is cubic root. In Bengali we call it ghanomul. So this is cubic root. So cubic root means, so a to the power 1 by 3 means cubic root of a. So again, here a, here with a there is no power. Inside the cubic root we have only a. So inside the cubic root we do not have any power. So in other way we can call it, we can say it like power is there, power is only 1. Power is only 1. So this 1 divided by 3 will be the power. So 1 divided by 3. Right. So next one. Here we have a to the power 3 square. So please notice here, there is no bracket here. There is no bracket here. If it was like this, bracket, if there was a bracket like this, in that case we could have had a to the power mn, right? But here we do not have any bracket. So that means here we do not have any bracket. Here a to the power 3, and on top of 3 there is power 2. So that means this here we have power 3 square. Here we have power 3 square. So 3 square, you know that 3 square means, 9. So a to the power 9. Again, here we have a to the power 3, bracket is there, and on top of bracket another power is there, which is 2. So that means, as I said before, if there is a bracket like this, power and power will be multiplied together. So 3 multiplied by 2, power will be a to the power 6. And always remember, if there is a 0 in the power, doesn't matter base is what, right? If there is a power over a base and doesn't matter, sorry, if there is a 0 in the power, if there is a 0 in the power over a particular base, doesn't matter what is the base, in that case we will have always 1. Answer will be always be 1, right? So that was the so we have discussed about rules of exponents or rules of power. Now let us solve one problem. So here the question is asking what is 3 to the power minus 3. So that means, in other way, the question is asking that if you want to remove the minus sign from the power, what we will have. So let us solve it. So as I said before, if you want to remove the minus sign from the power, what you have to do, you have to bring the whole thing in the denominator. You have to bring the whole thing in the denominator except the minus sign. So you have to bring the whole thing. That means you have to bring the base along with the power in the denominator except the minus sign. So in the numerator we will have only 1. So this is what we get. So we will have 1 by 3 to the power 3 means 27. 3 to the power 3 means 27. So that's the answer. Right. So let's solve the next one. Question example number 2. So here you can see there is 1 by 4 to the power minus 3. So here, as you can see, we have 1 by 4 to the power minus 3. So 1 will be there, and here again you have to get another fraction. You have to, in the denominator, you have to get another fraction to remove the minus from the power. So as I said before, you have to bring the base along with the power to the denominator except the minus sign. So we will have like this. So we will have 1 multiplied by, so that means the fraction in the denominator, the fraction we have in the denominator will get reversed this time. So that means the fraction in the denominator will be just reversed. So that means 4 to the power 3 will be in the numerator and 1 will be in the numerator. So what we have here now? So we have 4 to the power 3. We have 4 to the power 3, which is equivalent to 64. Which is equivalent to 64. Right. So that's the solution of the question number 2. Next, check out the question number 3. What we will have here, how we can simplify it, right? So as you can see here, we have, this is the cubic root. Inside the cubic root we have 64. Inside the cubic root we have 64, right? So 64 is 4 power 64 is 4 power 3. 64 is 4 power 3. So that means 64 is 4 power 3. So in other way we can write it like 4 power 3 by 3, 3 by 3, because here, as I said before, if you could have, if there were no power like this, in such case we could have had like this, because if there were no power like this here, if inside the cubic root, if there were no power like this, in that case we could have assumed that there is a power 1, right? So that means we could have had 4 to the power 1 by 3, 4 to the power 1 by 3 in such case. But we have here power 4 to the power 3 inside the cubic root. We have 4 to the power 3 inside the cubic root. So we will have 4 to the power 3 by 3. So these 3 always you will always remember, these 3 of the cubic root will always be in the denominator. So again I am saying, these 3 of the cubic root, these 3 of the cubic root will always go in the denominator of the power, and these 3, whatever power is there in here, this will be in the numerator. For example, if we had power 2 here, we could have had power 2 here. So that means if there were power 2 here, in that case we could have had power 2 here in the numerator. We could have had power 2 in the numerator. We could have, that means I'm saying again, if we could have had power 2 inside the cubic root, in that case that power 2 we could have had that power 2 in the numerator of the power. And always remember that these three of the cubic root will be in the denominator of the power, So here we do not have power 2, we have power 3. So here we will have power 3. So 4 to the power 3 by 3. So 3 and 3 cancels out. We have only 4. So that's the answer of this question. Right. So now let us solve example 4. Right. So here we have power. Here we have power 1 by 4. So that means you can see we will have so we will have 16 here first. So we will have 16 here first, and we will take power, we will take a fraction in the power, and as I said before, these four will always come in the denominator of the power. So these 4 will always come in the denominator of the power, and this power 3 inside the root will come in the numerator. So we will have 16 power 3 by 4. Right. So now again 16 can be written as 2 to the power 4. 16 can be written as 2 to the power 4, and we have power 3 by 4 outside. So instead of 16 we can write 2 to the power 4, because 2 to the power 4 equals to 16. 2 to the power 4 equals to 16. Right. and we have outside power 3 by 4. As I said before, now as you can see, so we have a power inside the bracket, we have a power inside the bracket, and outside the bracket we have another power. So as I said before, if there is something like that, what we will have is power and power will be multiplied together. So that means we will have 4 multiplied by 3 by 4. As you can see, these power 4 and power outside the bracket 3 by 4 will be multiplied together. So now what we have, so these 4 and these 4 will cancel out. So these 4 and these 4 will cancel out. We will have only power, we will have only 2 power 3. We will have only 2 power 3, which is equals to 8. Right. So that's the solution of that question. Now let us move to next one. Here we have cubic root, and inside the cubic root we have 8 to the power minus 2. 8 to the power minus 2. Right. So what we will have here? So here we will take 8 first. We will take power, and then we will take inside the power we will have a division, and inside the division we will have, so this power minus 2, as I said before, this power minus 2 will be in the numerator, and these 1 and these 1, these 3 will be in the denominator, right? So we will have something like this, right? So then again, as I said before, so we can write these one, this minus 2 can be written as like this, sorry, can be written as like this, can be written as like this. So that means these minus 2 can come in front of that power, in front of that power. So as I said before, if you want to remove the minus from the power, you need to bring the whole thing in the denominator. Okay, first of all, let's not bring it now. First, let us do some simplification, right? So instead of 8, we can write 2 power 3. So instead of 8, we can write 2 to the power 3 here. So that because 2 to the power 3 is 8. 2 to the power 3 is 8. We can write it like that. So now, as I said before, we have power 3 inside the bracket, and outside 3 another power is there, which is minus 2 by 3. So in such case, power will be multiplied together. So we will have 3 multiplied by minus 2 by 3. So 3 multiplied by minus 2 by 3 minus 2 by 3. Right. So like this. So now as you can, so I'm saying again, so this power 3 will be, so there is a bracket here, so the power inside the bracket and power outside the bracket will be multiplied together. So that means we will have power 3 multiplied by power minus 2 by 3. So these 3 and these 3 will be cancelled. These 3 will cancel out. So that means we will have 2 to the power, we will have 2 to the power minus 2, 2 to the power minus 2. So we will have 2 to the power minus 2. Now, as I said before, if you want to remove the minus from the power, if you want to remove the minus from the power, what you have to do? You have to take a fraction first. You have to take a fraction first, and you need to bring the base along with the power in the denominator, except the minus sign. So that means you need to bring the whole thing. You need to bring the whole thing in the denominator. You need to bring the whole thing in the denominator, except the minus in the power. So, and the numerator we will have only 1. So what we have now here, 1 by 2 square means 4. So we have 1 by 4. We have 1 by 4. So that's the answer of that question. Now let us solve a to the power 5. A to the power 5 divided by a to the power 7. Now let us solve a to the power 5 divided by a to the power 7. Right. So we will have what we will have? A power 5 minus 7. Why? Because you can see in the numerator also base a, in the numerator also base a, in the denominator also we have base a. So that means in the numerator also base a, denominator also base a. So bases are same, but powers are different. In the numerator we have power 5, in the denominator we have power 7. So in such case, we will deduct the denominator's power from the numerator's power. So that means we will deduct the denominator's power 7 from the numerator's power. So we will have 5 minus 7. We will have 5 power minus 7. Right. Sorry, we will have a power 5 minus 7. We will have a power 5 minus 7. So we will have a power minus 2. A power minus 2. So now again, if you want to remove the minus from the power, minus from the power, you need to bring the whole thing. In the denominator without the power. So we have 1 by a square. We have 1 by a square. In other way, we could have easily do it in very simple way also. Here you can see in the numerator we have power 5, in the denominator we have power 7. So these 5 and these 7 out of this will cancel out, and in the denominator only 2 will be there. In the denominator we will have only 2 in the power. So that's the solution of example number 6. Now let us solve example number 7. What we have here, right? So first of all we need to simplify. So here as you can see we have a power 3 over this 4x square. So here we will have power 4 to the power 3, and again so like this way. So as you can see we have here this power 3, this power 3, this power 3 is applicable to 4 and also x square. So that's why we have written it like this way. So we have written it like this way: 4 to the power 3 multiplied by x square and then power 3, right? So similarly, we have power 2 square and power and like this way. So that means we are distributing the power individually inside the elements of the bracket. So I'm saying again, we are distributing this power 2. We are distributing this power 2 to all the elements of the inside all the elements we have inside the bracket. So that means we are distributing this power 2 to all the elements we have inside the bracket. So we have 2 square, and then we have x cube power again 2, right? So now again, so let us do the same way like here. We have like this 6 square and then x cube whole square. So similarly we have this, right? So now right, so instead of 4 cube we can write it like 16. Sorry, it's not 16. 4 cube. 4 cube means 64. 4 cube means 64. And here, as I said, here we have x square bracket power 3. So this power 3 and this power 2 will be multiplied together. So 3 multiplied by 2 is x to the power 6. So we will have x to the power 6. X to the power 6. So here again we have 2 square. So 2 square can be written as 4. Then again we have x cube. So this 3, this power 2, this power 2 and this power 3 will be multiplied together. So we have 3 multiplied by 2, we have x to the power 6, right? Let me check again if I have written right or not. Yes, it's correct. So then again we have here 6 square. 6 square, we can write 6 square as 36. So here we have x cube bracket square. So this power 3, this power 3 and this power 2 will be multiplied together. So 3 multiplied by 2 is 6. Right. So this 3 cube can be written as 27, and this one can be written as this power 3 and power 2 will be multiplied together. So we have 3 multiplied by 2 means x to the power 6. Right. So cancels out. Right. So now as you can see, these x to the power 6 in the denominator, and here also x to the power 6 in the numerator. So these will be cancels out. These will be cancel out. So right. So x to the power 6, x to the power 6 will cancel out. And here in the denominator we have 4. Here in the numerator we have 64. So 64 divided by 4, we are left with only 16. So that means I'm saying again, from these one we get only 16. We get only 16. How? This x to the power 6. So let me write it in another way. Let me simplify again. Simplify it so that you can understand. So this x to the power 6 and this x to the power 6 is numerator also x to the power 6, denominator also x to the power 6. So these will be cancel out. These will be cancel out. These will cancel each other. Right. Now we have in the denominator 4. In the numerator we have 64. So if you divide, we will get only 16 here. We will only get 16 here. Similarly, we have here also numerator we have x to the power 6. In the denominator also we have x to the power 6. So these will cancel each other. So they will cancel each other. They will cancel each other. So in the denominator we have 27, in the numerator we have 36. So if you divide, if you apply the process of cancellation, in that case we have in the numerator we have 4 multiplied by 9. In the denominator we have 3 multiplied by 9. So that means we can write it like this way. So 4 multiplied by 9, 36. In the denominator we have 3 multiplied by 9. So this 3, this 9, this 9 and these 9 will cancel out, will cancel each other. So we have these one and these one will cancel out. So we have 4 by 3. We have 4 by 3 only. Right. So we have the answer is 16, not 16, 17, 17.3333. So this is the answer. So this is the answer. I hope you understand. If you find any problem, obviously you can knock me. You can knock me over Skype. You can knock me over Messenger group. You can knock me over mail. You can also call me. But please remember, if you do not understand, if you fail to understand any part of this, any problem, please do not hide. Please do not hide. Please share your problem with me. I will always help you. So now let us solve this one. Right, so what we have, as I said before, we can write it like, we can distribute the powers inside we can distribute this power 4, we can distribute this power 4 to all the elements inside the bracket. So we have 2 to the power 4 bracket x square and power 4. So again we have what we have here. We will have 4 square and then like this. What we will have here, we will have 2 square and like this. What we will have here, four cube and this, right? So let me check again if I have written, if I have typed correctly or not. Okay, it's okay. Right. Right. Yes, correct. So instead of 2 to the power 4, we can write 16. Here again we have power square, x square, and there is a bracket, and outside the bracket we have power 4. So this power 4 and this power 2 will be multiplied together. So that means we will have power 6. So power 6. So in the denominator we have x to the 2 square. We can write it like 4. Again we have here we will have 6, because these 3 and these 2 will be multiplied together. So x to the power 6. So again these one can be written as 16, and we will have power 4. So now we have 4 cube. 4 cube means 64. Here we can write like 3 multiplied by 2, that means 6. So let me check if I have written correctly, if I have typed correctly. Yes. No, this one is not correct. 4 multiplied by 2 is 8, should be 8. Yes, 8. So to the power 16, and x square power over 4 is like we will have x to the power 8. So here 4, x to the power 6. Here we will have 16, and x to the power 4. Here we will have 64 and x to the power 6. Yes, now it's correct. So you should always check if you have written correctly or not. You should always check. Right. So now this 16. So first of all, this one here we have x to the power 8. Here we have x to the power 6. So if we apply process of cancellation, this x to the power 6 will be cancelled out from this x to the power 8, and the numerator we will have only x square. In the numerator we will have only x square, and this x to the power 6 will be cancelled out, right? So these will be like this. Then again this 4 and this 16, if we apply process of cancellation, we will have only this 4 will cancel out, and we will have only 4 here. So 4x square. So denominator we do not have anything, so that's why we can write it like this way. So 4x square. Right. So now this one. Here we have 16. So now let's do this one first. Here we have x to the power 4. Here we have x to the power 6. So if we apply process of cancellation, this x to the power 4 will cancel out, and we have only x to the power 4. That means 4 we will have x to the power 4. That means we will deduct 4 here from 6. So we will have only power 2. So it will be like this. Now we have here 16. Here we will have 64. So if we apply process of cancellation, we will have this 16 will be cancel out. So we will have only 1 there, and so we will have nothing there. So this 16 will be cancel out, and this 64, if we cancel out, we have only 4 here. So since we do not have anything here in the numerator, we will give 1. Right. So now again, so if we take 4x square common, if we take 4, so I mean, you can keep it like that. You don't have to take a common. Okay, you can keep it like that. That's good enough. That's good enough. Okay, that's good enough. You can keep it like this way. So that's the answer. That's the answer. Right. I hope you understand. If you fail to understand anything of this problem, please contact me as soon as possible. So now we will solve the example number 9. So you should be able to do it now very easily, because I have already explained similar problems before. So what we will have here, we will have 16 power, sorry. We need to take the power first, power, and then a fraction. So as I said before, these 4 will come in the denominator. This 4 will come in the denominator, and this power minus 3, this power minus 3 will come in the numerator. So it will be like this: 16 power minus 3 by 4. Right. So this 16, instead of 16 we can write 2 power 4. Instead of 16 we can write 2 power 4. So what we will have? We will have 2 power so as I said before, this power 4, we have power 4 inside the bracket, and outside the bracket we have power minus 3 by 4. So these both of these power will get multiplied. So what we have, so it will be like this. So that means both of this power will get multiplied. So now what we will get? These 4, and these 4 and these 4 will get cancel out. So that means we will have only 2 power minus 3. We will have only 2 power minus 3, which will be like, as I said before, if you want to remove the minus sign from the power, you need to bring the whole thing in the denominator. So that means if you want to remove the minus from the power, you need to bring the base along with the power in the denominator except the minus sign, and the numerator we will have only 1. So what we will get? We will get 1 by 8. We will get 1 by 8. Right? So let me check if I have typed correctly or not. Yes, it's correct. 3 by 4, correct. So cancel out 2 to the power minus 3. Yes, it's correct. Absolutely correct. So you need to always revise after you solve a problem, because you may make a mistake in solving the problem. So that's the answer of that question. Example number 9. Now let us solve example 10. Right, so what we have here, 8 to the power minus 4 by 3. 8 to the power minus 4 by 3. Okay, so We have 8 to the power minus 4 by 3. Instead of 8, we can write 2 power 3, because 2 to the power 3 equals to 8. 2 to the power 3 equals to 8. So what we will have here? We will have 2 power 3 multiplied by minus 4 divided by 3. So we have 2 to power 3 multiplied by minus 4 by 3. So now what we have? So as I said, these 3 and these 3 will cancel each other. So we will have 2 power, we will be left with only 2 power minus 4. 2 power minus 4. 2 power minus 4. So that means we will have, so as I said before, if you want to remove the minus sign from the power, you need to get a fraction first, and the base along with the power will move to denominator. Base along with the power will move to denominator except the minus, right? So in the numerator we will have only 1. So what we will have? 1 by 2 to the power 4, which means we will get 1, and 2 to the power 4 means 16. So let's see if I have done correctly or not. Yes, 8 to cube, right, it's correct. 3 cancel out. Minus 4, power minus 4 is yes, 1 by 16. Correct. So that's the solution of example number 10. Example number 10. Now let's solve example number 11. Example number 11. Right. See here, you can see all the bases are x. All the bases are x. See, these dots are these dots indicate multiplication. These dots indicate multiplication. This x is not multiplication. This x is letter x, right? So here we have, this is base x, here also base x, and in all these cases we have base x, but powers are different. And as I said before, the rules of exponent indicates that, rules of exponent dictates that if the bases are all same and if you are multiplying, in that case powers will be added together. Powers will be added together. So x power, sorry, x, we need to get the power first. X power 3 by 2 plus let me get a fraction again. Three by 2, 1 by 2 plus 5 by 2, and then we have these. We have these, right? So you can see x power 3, all the powers are added together. Added together means Here we have 3 by 2. Here we have power half. Here we have power 5 by 2. Here we had power minus half. So that means all these are written 1 by 1. Right. So now what we have? Right. So here, as you can see, in the power, the fractions we have in the power, in those power we have all denominators. In the denominator we have all two same denominator. So that means what we will have LCM is same. LCM will be always LCM will be same. Right. So we will have 3 plus 1 plus 5 minus 1. So like these, 3 plus 1 plus 5 minus 1. Correct. So what we will have? We will have 3 plus 1 4, 5 plus 4 9, 9 minus 1 8. We will have 8 there. So 3 plus 1 4, 5 plus 4 9 minus 1 8. So 8 divided by 2, we have x to the power, x to the power 4. We will have x to the power 4. So that's the solution. Let me check again if I have typed correctly or not, because it's difficult to whiteboard is easy. It's difficult to type in math type, and math equations typing is not so easy, so you may do mistake. I need to check again if I have typed correctly or not. So right, correct, and then 3 plus 1 4, 5, right, 8 by 2 4. Yeah, that's correct. So it's correct. So that's the solution of example number 11. Now we will solve this one. So here the question is asking, find the value of x. Find the example number 12 is asking, find the value of x if 8x to the power 7 by 2. Find the value of x if 8x to the power 7 by 2 is equal to 72. Right. So let's solve this one. So right, whenever you get equation like this, always remember that similar items should be brought to similar places. So that means I'm saying again, whenever you want to solve an equation like this, you have to bring similar things on the same side. So here we have 8, here we have 72. So that means you need to bring this 8, on the right hand side. So these numbers, the isolated numbers should be brought together in the same side. So that means these 8 should be brought to this 8 should be, we should bring this 8 to the right hand side. So as you can see, this 8 is in multiplication. That means here this 8 is in multiplication with x to the power 7 by 2. বাংলায় যদি বলি এটা গুণ অবস্থায় আছে. So that means here the 8 is in multiplication with x to the power 7 by 2. So that means if we move this one to right hand side, it will be reversed. That means it will be in the denominator, in the right hand side. So that means it will move to numerator, and these 8 will be in the denominator. So that means I'm saying again, that means you need to bring the similar items on the same side. So that means you need to bring this 8 on the right hand side, and this 8 is in multiplication. This 8 is in multiplication condition with x to the power 7 by 2. And if you bring this one to right hand side, it will be in the denominator. That means it will be the operation will be different. Operation will be now not multiplication, operation will be division. Right, so what we will have, so here if you apply process of cancellation, you will get 9. Now as I said before, always remember, if you want to find the value of x, only x should be on the left hand side, except that everything else you should bring everything else on the right hand side. So that means if you want to find out the value of x should be on the left hand side, and all other things you should bring all other things to right hand side. So right, so this power we will move this power from left hand side to right hand side. We will move this power from left hand side to right hand side. We will move this power from left hand side to right hand side. But now always remember, power moves from one side to another side as power. So power will always move from one side to other side as power, but it will be reversed. We will get a inverse of that power. So that means here we had 7 by 2, but when we will move it to that side, we will get 2 by 7. Excuse me. So I'm saying again, here we had power 7 by 2. If we move this power from left hand side to right hand side, in that case power will move as power. So that means power will go as power only, but it will get reverse. If you move it to move from one side to another side, the power will be reversed. So 7 was in the numerator, 7 moved to denominator, 2 was in the denominator, 2 moved to numerator. So it has reversed. So you can keep it like this way. That's fine. So that's the answer. That's the answer of x. That's the solution of x. So x, the value of x is 9 power. So 9 power 2 by 7. Let me revise again. Let me see if I have typed correctly. Yes, 8 is moved to right hand side. So that means 8 nong 72 9. Okay, yes, it's moved to that side. So 2 by 7. Yes, it's correct. So that's the solution of this question. Right. So let's solve example 13. Let us solve example 13. Here you need to find the value of q. Here variable is q. Here the variable is q. You need to find the value of the variable which is q. Right. So as I said before, you need to bring similar items on the same side. So that means you need to bring this 9 to right hand side. You need to bring this 9 to right hand side. So that means this 9 is in multiplication. This 9 is in multiplication in the left hand side. if you move this 9 to right hand side, the operation will be reversed. Operation will no longer be multiplication, operation will be division now. So that means this 9 was in multiplication in the left hand side. If you move it to right hand side, it will be in the denominator. So if you divide this one, 58.5 divided by 9, we get 58.5 divided by 9. 58.5 divided by 9. 58.5 divided by 9, we get 6.5. So 58.5 divided by 9, we get 6.5. So that means 6.5. Right. So now what we will have, Q as I said before, you need to move this power. As I said before, if you want to find the value of Q, only Q should be on the left hand side. Other than Q, everything else should be moved to right hand side. That means you should move all other elements to right hand side except Q. So we need to move this power 3 by 8 to right hand side. As I said before, power move as power always. So if you move that power to right hand side, you will get reverse of that power. So it was 3 by 8. Now we will get 8 by 3. So the power was 3 by 8, and when we move that power to right hand side, power moved as power. Power always move as power, but we will get a reverse of that power. So that means 8 was in the denominator. Now 8 will come in the numerator. 3 was in the numerator. 3 will come in the denominator. So these will be like these. So that's the answer of Q. So the value of Q is 6.5 power 8 by 3. Right, so now here what we have here. Right, example 14. If Q power 3 is equal to 8, and if P is equal to 4Q bracket power 5, then find the value of 3P to the power 2 by 5, and the number 2 is 9P cube multiplied by Q to the power 5 by 2. So then see here we have two questions are there. You need to solve it. You need to find the value. Right. So first of all, here we have Q cube is equal to 8. Let us first find out the value of Q. Right. So here we have Q cube and 8. Instead of 8 we can write it like 2 power 3. So instead of 8 we can write 2 power 3, 2 power 3 very easily, right? Always remember, if you are solving some equation like this, and if you see that in the left hand side also power is this in the left hand side and the right hand side powers are same, here also power 3, here also power 3. In such case the bases are equal to each other. So that means here q is equal to 2. Here q is equal to 2. So that means here q is equal to 2. So here q is equal to 2. So here q is equal to 2. So that means, I'm saying again, if you see that in the right hand side also power same and the left hand side also power same, so in that case the bases will be equal to each other. So bases are q is equal to 2. So that means this is the value of q, right? So now let us solve this one. Let us find the value of q now. Right, so this is multiplication sign, not x. Remember, this is multiplication sign, not x. So 4 multiplied by q, the value of q is 2. So 4 multiplied by 2 power 5, right? So what we will have, right? So we will have 8 power 5, 8 power 5, right? So we will have 8 power 5. So 8 power 5, 8 power 5 8 power 5, 8 power 5 is equal to 32,768. This one, right? So this is the value of p. Now the first question is asking us to find out let me actually solve it in a different way. It will be easier. It will, otherwise you will fail to understand. I mean, to make it simple, I need to make a little correction here. Let me not solve it this way. Let me solve it in other way. Right. So let me solve it in other way so that you understand easily. Let me do it directly. So let us find out the value of this one first. First question was asking us to find out the value of 3p to the power 2 by 5. Right. So let's solve it directly. Let's not find the value of p individually. Let's solve it directly. So what we have? So instead of p, we will bring this one here. The value of p is this one. So instead of p, we can write this one. we can write this one, right? So as you can see, instead of p is replaced by the value of p, which is 4q bracket power 5, right? So I'm saying again, we have replaced the value of p. We have replaced the value of p by 4q bracket power 5. We got it from here. Right? Now what we will have. So here you can see we have power 5, and outside the bracket we have another power. So as I said before, if you have something like that, power and power will get multiplied by each other, right? So what we will have, this is a multiplication sign. Remember, this is not an x. This is multiplication sign. So here you can see these 5 and these 2 by 5 get multiplied by each other, right? All right. So now if you apply process of cancellation, these 5 and these 5 cancel each other out. So we will have only 3 4q bracket square, right? So what we will have now here, so we will have right. So q, instead of q, the value of q is 2. Now we can replace the value of q here. The value of q is 2. So remember again, this is not an x. This is a multiplication sign, and the value of q is 2. So what we will have? We will have this 4 multiplied by 2, which is 8. So 3 8 square, right? So 3 bracket 8 square. So 8 square is 64. So we have 3 multiplied by 8 square means 64. So if we multiply 3 multiplied by 64, 3 multiplied by 64, we will get 192. So the answer is 192. So the answer of the first question is 192. So let me check it again if I have written correctly, if I have done the problem correctly or not. P is 4q to the power 5, yes, and this cancels out, so we have 4q square. So q, the value of q is 2, right? Okay, so 8 square 64, yes, 192 is correct, absolutely correct. So you should always revise it like this way, because you may make a mistake. So now we will solve these one. Now we will solve this one, right? So okay, all right. So again, the value of p is this one. So we will replace the value of p. we will replace the value of p. So value of p is this one. So we have replaced the value of p by this, and except that everything else is same, right? So now we have like this. Okay, that's good enough. All right, so now let's solve it. Let's go further. Excuse me. Right, so here you can see we have what we have here. There is a power 5 over 4q. So this power 5 is not only on q but also on 4. So we will distribute this power 5 to all the elements inside the bracket, inside the bracket. So we will have here power 4 to the power 5 q to the power 5. So that means we had 4q bracket power 5. So what we have done is we have distributed this power 5 to 4. We have distributed this power 5 to inside. We have distributed this power to q also. So 4 to the power 5 multiplied by q to the power 5, right? So 4 to the power 5 multiplied by q to the power 5. Now again, now we will distribute this power 3 to all the elements of inside materials, right? So if you do that, if you distribute this power 3 to this power 5, so that means it will be, we will have, okay, ja amma bashay nai. Right, so we will have, what we will have? We will have these. Right, so that means what we have done is we have distributed this power 3 to all the elements of inside materials, okay? Right, so now what? Now what? So what we have here, 4 to the power 5 multiplied by the, so that means here you can see this power 5 and this power 3 will get multiplied by each other because there is a bracket there. So 3 multiplied by 5 means 15. So we will have, this is a multiplication sign, remember. So we will have 15, power 15. We will have power 15, 4 to the power 15, and here we have 3 power multiplied by 5. Again we will have power 15. We will have power 15, right? We will have power 15, right? So we will have something like this. Right, so right? So now as you can see, here also base q, here also base q. So in that case, since the bases are same and we are doing multiplication, so the powers will be added together. So that means this 5 by 2 these will be like this, right? Okay. So I'm saying again, here we had power q, here we have power, here we have base q, here also base q, and both of these are in multiplication, and because of that, powers of each of these base will be added together. So 15 plus 5 by 2, right? So now what we will have, so you can see if we do LCM, we will have 15 plus 5, right? Not 15, 30 plus 5. Or in simple way, you can write it like, in simple way, you can write it like 17.5, right? Okay, so now what? So instead of q, the value of q, is 2. So now we can replace the value of q there. So value of q is 2. So now we can write like 2 here, and here instead of 4 we can write 2 square. So we can write 2 square there. So I'm saying again, I'm repeating again. So these 2 square, instead of 4, we can write 2 square there. Why? So that we can match it with this base 2. So to match it with this base 2, we can write this 4, convert this 4 to 2 square, right? Right, so now what we will have 2 square. So here, as I said before, this 2 power 2, there is a bracket here, also power 15. So this power 15 and this power 2 will get multiplied by each other. So that means we will have power 30 here. 15 multiplied by 2, that means 30. So I'm saying again, these 2 and this power 15, there is a bracket there. So 15 multiplied by 2 is 30, 2 to the power 30. Then again, you can see here also base 2, here also base 2, and here also base 2, and we are doing multiplication. So in that case, powers will be added together. So 30 plus 17.5. 30 plus 17.5. I'm saying again, here also base 2, here also base 2, here also base 2, and here also base 2, and in the middle we are doing multiplication. So since the bases are same and we are doing multiplication, this power 30 and this power 17.5 will be added together. So we will have in our hand is we will have in our hand is 47.5. 47.5. So 47.5. So 2 to the power 47.5. So we can keep it like this way. We can keep it like this way. So let me do the revision here. So let me do the revision now. So this was the problem. This was the problem. Here P is equal to 4Q to the power 5. 4Q 5. Yes. And then we have this. So cancels out. We have 4Q square. Yes. No, sorry, I'm solving this one, second one. First one already revised. So we are solving this one. So we have this one is yes, this one. So P is 4Q power 5, 4Q power 5, 4Q power 5, and over that we have power 3. Yes, that's it. So 4 to the power 5, Q to the power 5, 3. So Q to the power 15. So this, yes, 40 bar 15, yes. So we will have 4 to the power 15, q to the power 15 multiplied by q to the power 5 by 2. That's it. So 17.5, 4 to the power 15, yes, correct. And then we have 2 square, yes, 2 square 15, 30, and we have q is equal to 2 to the power 17.5. So we will have 2 to the power 47.5, 9 into 40 to the power 47.5. So that's the answer. It's correct. Right. So yes, so today we will end here. Already 1.5 hour lecture is done. So today we will done here. We will stop here, and next class we will continue. Next class we will continue from question number 15. So next class we will continue from question number 15, example 15. So today up to here. Okay, so that's the end of lecture 1.